This is geometry review, part 2 for 1 through 30. Okay. Question number 13. All right. So this question is going to talk about the trapezoid. It wants to know the area of the trapezoid if its parallel sides measure 16 and 32 feet and it's got a height of 16. All right. So parallels, let's see. Of a trapezoid measure, what did I say? 16 and 32. Height of 16 feet. Solve for area. All right. This is where it comes on you guys. It's going to give you information like that. It's not going to give you a picture. You have to know what the formula for the area of a trapezoid is. Okay, you got that part right.
Multiply height, right? And divide by 2.
Multiply by height, divide by 2. Okay, that's our area of a trapezoid formula. The rest of this, you're going to take the information that's been given and you need to accurately sub it in. So what is B1? Base 1, okay, which is, in this case, 16 plus 32 by 16 and divide by 2. So 16 plus 32 gives you 48. 48 times 16, 768. Divide by 2, 384. And this is feet, what? Feet squared. Okay? 384 feet squared. Big thing is that you need to know the formula and how to plug things into it. Okay? More often than not, the thing that typically gets forgotten on any area formula is the divide by 2 portion of it. Okay? So just be aware of that. All right. 14. Okay. It's going to tell you, it's not going to give you a picture for this either, it's just going to give you the information. It's going to say that the arc of a circle measures 48 degrees. Let's see. The circle has a radius of 7 meters, let's say 7.5 meters. We want to know what is the arc length. Okay? What is the arc length? And it wants it to the nearest hundredth. There is a formula for this. Does anybody know what it is? The n minus 2? No. Okay? Arc length of a circle. What is that based upon? We can either find the area of a circle or we can find the circumference, right? So arc length, is that associated with the area of the circle or the circumference of the circle? Circumference, yes. Arc length is a fraction of the circumference of a circle. And that's important. It's an important way to understand it. Okay, because what is the formula for the circumference of a circle? What? Pi d, there's another one though that's a little bit more useful.
R squared.
No, you're thinking of area. This is one you got to know. 2 pi r. Okay, because it's giving me measurements in radius, which is why I think you need to know beyond just pi times diameter. 2 pi r. Now, we're not looking for the entire circumference of the whole circle. We're looking for a fraction of it. Okay? That's why they gave you 48 degrees and not 360 degrees. Okay? So, we're going to take the measure that they've given us and put it over 360 to find out what that fraction is. Okay? So it's your fraction of your circle times the circumference formula. If you don't know this formula, you're going to need to know it tomorrow. Okay? So now we just go in and substitute. So I'm writing 2 pi what? 7.5 times 48 over 360.
So is it, what is it, 2 pi 7.5? Would it be like 2 times 3 point whatever?
It would be the same as pi times 15. See what I'm saying? Because multiplication is commutative. You can do that. Yes, you can do 15 times pi times 48 divided by 360. If I was going to do this, right, I would pull up my graphing calculator like this. I don't need any of that. Okay.
You should just have like a paper. You just have a computer copy.
Well, 2 pi 7.5 48 divided by 360. Okay? So wanted it to the nearest hundredth, right? So our answer would be 6.28 meters squared, or sorry, just 6.28 meters. Why is it not meters squared? Because we're not finding area. We're just finding length of something. Okay? All right, can we do that? Or are we completely lost on that? Okay. Okay. All right. Number 15, it will give you a picture of a parallelogram, and it's going to ask for you to find the area of it. Give you something like this. I mean, in the first 12 questions, I don't remember off the top of my head how many of them you need to go back and plug in. Okay, so we need to find the area of this parallelogram. How do I find the area of a parallelogram? Okay, the fact that it says it's a parallelogram is really important. Okay, let me see if I can show this to you in a way that kind of will help you remember how a parallelogram is going to work. All right, you see this dotted line here? That's where they make the height line at. Imagine, imagine that's on a sheet of paper. Whenever you see a dotted line, a lot of times it's usually, they show it as a line where you can cut, right? All right, so if I were to take a pair of scissors and cut that, right, and then slide it over here, right, what I would have then is I would have this dotted line, and I would have this, right, and that piece that I cut off would fit perfectly right here, All right, so finding the area of a parallelogram, the formula is just base times height. Because that 5.4 line is right here, and that 22 is right there. Okay, so all I'm doing is taking 5.4 times 22. Does that make sense? Okay, so 5.4 times 22. Okay, 118.8. Should be. Okay, but as I'm hearing here is that nobody knew what the formula was. $16. All right. Let's see. They're going to give you circle look like that somewhat. I felt like I did pretty good there. Let's see. They're going to say this is like 72 inches. Okay, and they do mean that to be all the way across. They want you to find the circumference. Okay, let's see. They want you to use 3.14 for pi. Okay, so you're just taking 3.14 times 72. Nope. 226.08. Okay. And either do 2 pi r, or in this case, it's easier to do pi times diameter. Okay, questions? And if you look at this question on the test and you're not sure if that length across, you see a number where 72 is situated and you're not sure if that's radius or diameter, you can ask, okay? Because you're not being tested on whether or not you can identify it as a radius or a diameter. You're being tested on whether or not you can take that number and put it in the formula correctly. Okay, let's see. They'll give you another circle, something like that. Let's see. I'm going to ask you to find the area. What's the formula? No. No. Pi r squared. How can you remember the difference? Because obviously we don't. How can I tell the difference between pi r squared and when to use it versus 2 pi r? Because the problem is they both have pi, they both have r, they both have 2, right? And people are getting them flip-flopped all the time, and it has been going on in my classes for years. How can I tell the difference between those two things? All right. Right. And that's what I want you to understand is that whenever I solve for area of something, it's in units squared. Okay? Whereas if I'm finding the lengths, right, there's no square involved. Okay? Does that help? Okay? So I know I'm going to have a pi, an r, and a 2. The question is, all right, when do I use pi r squared or 2 pi r? Okay? The question is, am I finding area? If I'm finding area, I want it squared. Okay? Does that help? Okay. So what we're going to use here is we're going to use 3.14 times 5 squared. All right? Should give me 78.5 feet squared. So pi r squared ends in units squared. Okay. And I guarantee that if you don't know the difference, you're going to get these questions wrong, because if they're multiple choice, one of those multiple choice options is going to be you using the wrong formula.
That's actually pretty good.
I thought so. All right. That's 17. 18. A lot of circle stuff in this. That's a little more ovally than it is. Let's see. Yeah, it's not great. Um,
Sorry, Cal, that's good for everybody else in this class. It's not the
all right, this should be the easiest question on the test. But I guarantee that several, if you don't remember this one thing, will get this wrong. There's not even actually any math to do. There's no math to do here. It's 96 degrees. Okay? It's 96 degrees. Does anybody know why? Okay? What is the measure of arc YZ? The reason why it's 96 is because this is a central angle, and a central angle is always the same as the intercepted arc. Okay? So if the central angle is 96 degrees, then the arc that intercepts it is going to be 96 degrees. Does that make sense? Okay? If I was going to be real particular, I would make you explain that on the test, because literally it's couldn't be any easier. Probably, yeah. I guarantee there'll be somebody that says, "Oh, well, it must be this way around, right? It's got to be that way around." And so it's probably, I guarantee that the people that get it wrong will take 360 and subtract 96 and get, whatever that is. And it probably will be an option, and they'll put 264 degrees on there. Okay? It's not 264 degrees. All right, 19. Okay? Okay? This wants your answer in simplified radical form. Okay? How do I solve for x? Reagan? Do you remember the Pythagorean theorem?
Oh yeah. A squared plus B squared equals C squared.
Cool. A squared plus B squared equals C squared. Now what goes where? Okay, good. So 12 plus 6 equals what? X? Okay. All right, so what, 18? 18 equals X? Do what? Square what? Okay. Okay, what's 12 squared? Okay. What's 6 squared? 36. need to square that too, right? Okay. 144 plus 36.
Don't look at me.
You think it's 180? 180, okay. 180 equals x squared. A bunch of people will stop there, right? Like Garrett. Okay, what's left? Plug it back in? No, not the. Do what? Tatum? Square root both sides. All right, this is why it says simplified radical form. Okay, because we're going to take 180, right, and we want to break it down into its prime parts, right? What can I divide 180 by? 2? 2 and what? 90? Okay, what can I divide 90 by? 2 and 45? What can I divide 45 by? 9? Let's do 5 and 9, 3 and 3, right? Okay, what's the simplified form? 2? I got 2 2s and 2 3s. So 6 radical 5 is my answer. Okay, do you guys understand why it's 6? Because 2 pairs of 2s come out as 1 2. 2 pairs of, or 2 3s come out as 1 3. 2 times 3 is 6, leaving me with 5 that remains inside the radical. Okay. Last question on the test. Okay. And let's see. I kind of just want to leave this one for you guys. Just leave it? Okay, good. It's a proof. Nothing, don't worry about it.